So there are various methods to control the speed of DC motor, and in this video we are going to explore two of them. So first we'll get a DC motor for our operation. So for that we'll go to SimCaps. This is really important. You should know from where you are getting the components. In SimCaps you should go to Power System and then Simplified Technology and then Fundamental Blocks. So we are going to use most of the component from this fundamental blocks. Now first we'll take our machine. So here we have the DC machine. We'll add this to untitled model and then we'll get the source. We want DC source. And now we want a constant block which is available in sources. This is the constant block we want. Now we'll arrange all these things and prepare a simple circuit. So we'll open this DC machine and we're going to select which machine we are going to use. So we'll use this first one, 5 HP and 240 volts, right? If you want to use any of these, you can go for it, right? You can even go for 10 HP, 20 HP, anything you can go for if you wish to go. So here we'll start with 5 HP. For mechanical input, we have three options: torque, speed and mechanical rotating port. So we are going to use this torque and it's a wound rotor motor. So in parameters, all these preset parameters we are going to use, and in advanced is sample time. So we are not going to do anything in this. So this is the block parameter of our DC machine. While performing this simulation, if you find any difficulty and doubt, then you can ask me in comment section regarding these parameters. Now in this parameter we have seen that it is 5 HP, 240 volt and field is 300 volts. So we'll give 240 volt to armature and 300 volts to field. So here what we'll do, we'll use two separate DC sources for this machine. One for the armature and the another one for the field. So first let's connect this source to armature. And now we'll connect this to field. This is the torque and we'll connect this constant block over here. Now from this port we are going to measure different measurements of this motor. The list of measurements you can see over here. So what we are going to do, we are going to use Dmux. So Dmux will connect this. We'll double click this Dmux and we'll convert one input into 4 outputs. So now we'll get 4 outputs over here. Now we'll get a scope. Here you can see that the speed is in radian per second. So what we want to have the speed is in revolution per minute, in RPM. So what we'll do, we'll add a gain block in order to convert this radian per second into RPM. So for that we'll use gain block and we'll use this gain 9.549298. This will convert radian per second into RPM. So now this signal is our speed in RPM. Now how do we want all this 4 graph to appear? I don't want it to appear in single screen. So what I'll do, I'll create a 4 separate graph and then I'll see each of the things in individual graph. After this we need one power GUI block. So we'll use this power GUI block, we'll add it over here and now we'll set the source voltage 100 and we'll set it to 240 volt and the field supply is of 300 volts. So I think almost everything is done. Now let's run this and there we go. Here you can see the speed has initially increasing and then it's stable to a point. The initial current is very high and then gradually reducing. So you can see the current is almost 2.225 ampere. So here the first is speed, this is armature current, this is field current. You can see it's almost constant from initial value. And the last one is torque produced. So torque will also be almost constant because the load is constant. So the torque produced by the motor is almost constant. So these are the parameters, and now we are going to understand how we can regulate the speed. So in order to regulate the speed, what we'll do, we'll add some resistance in series with the armature winding, and then we'll observe that what is the effect of resistance on the speed of armature winding. So we'll get some RLC branch and we'll convert it to R and make a 10 ohm resistance. If you want to see the significant difference in speed, you can increase the amount of resistance. So this is R1. We'll add another resistance R2 and we'll add another resistance R3. So these are the three resistances. Now we'll use idle switches to connect or disconnect this resistance while simulating. So we'll have this idle switch. So we have three switches over here. In order to operate the switches, we are going to use the step input. We'll open this. This is the step time, at what time we want to switch from initial value to final value. So let's say we want to switch after 2.5 seconds. And in this we want to switch after 5 seconds, and the third switch we want to switch after 7.5 seconds. So after the interval of every 2.5 seconds, we are going to switch one of the resistance. Initially all these three resistance are connected in series with the armature winding, but after 2.5 seconds, the first resistance will be cut off. After 2.5 seconds, the second one, and after 2.5 seconds, the third resistance will be cut off from the circuit. So after 7.5 seconds, there will not be R1, R2 and R3 in the circuit. So now let's run it and observe what is the effect of this series resistance on the speed of DC motor. Now here you can see that the speed is increasing gradually, and after 2.5 seconds the resistance is cut off from the circuit. So again it will start increasing. After another 2.5 seconds, again one resistance is removed from the circuit. So again it's rising. It's stabilized after some time, and after 7.5 seconds the last resistance is also removed from the circuit and speed again bumped up, and it's almost over 2000 rpm. Now we'll do the same thing with the field winding. Now here we'll update this voltages. It's 240 volt and this one is 300 volt. Now here you can see that we have connected three resistors in series with the field winding, and this voltage is directly given to the armature. In this part of the simulation, we are going to change the resistance in field winding, and we are going to observe what is the effect of that on the speed of motor. So now let's run. And here you can see that the speed has initially at its peak and then it's gradually reducing. So here you can see that initially all these three resistors are connected in series with the field winding. So the current of field winding is minimum. You can see over here. And because of that, the speed is maximum. But after 2.5 seconds, we are removing this R1 resistance and current flows through this path, right, through this field winding. So the current through field winding has increased, and because of that, the speed has decreased to a little lower value. After 2.5 seconds, the same thing happens and speed again reduces, and after 2.5 seconds, this R3 resistance also removed from the circuit, and this 300 volt is directly given to the field winding, and hence the speed further reduces. So as you are dealing with the field control of DC motor, as you reduces the resistance, the speed also reduces. And in armature control, as you reduces the resistance, speed increases.